Good morning, ladies and gentlemen. It occurred to me that if today is Thursday, we have this day, and then we have Monday, Wednesday, and Friday of next week, and we are done with regular school. After that, it's exams. So we really have 4 days, this being first of the 4 days. And so what's going to happen is we're going to cover some new material for 3 days, and then we'll take a quiz or test on it on the fourth day. I have great news for anybody who's feeling like they're struggling a little bit. This next 3 days is going to be the easiest material that we cover ever in Trig. Okay, and so each day is going to be a little bit different, but they're going to keep kind of building on each other a little bit. So today, as you can see, we're going to talk about the law of sines. So if you don't yet have something with which to write and something on which to write, go ahead and get it out so we can talk about the law of sines. Okay, the first thing I'd like you to do is I'd like you to go ahead and draw just some generic triangle real quick. Just like this, draw some generic triangle. And I want you to label it by the corners A, B, and C. And I'm not sure if you know this, but the side opposite, this side right here, which is opposite of angle A, is actually called A with a lowercase a. And this side right here, opposite of angle C, is called C with a lowercase c. And the same thing here, this side clearly then is called B, lowercase b. And that's the notation we'll see that we've seen so far this year, and we will continue to see. Now, in geometry, a lot of times, my students are, let's do this. We'll talk about how, this side right here is called side AB. And I agree with that, but in this context, it would be a lot easier if we refer to that as side C, okay? And so capital letters are for the angles and lowercase letters are for the sides. All right, so this is the law of sines. Great news about the law of sines is you can't forget it once you hear it. The law of sines is just a system of ratios that is true for every triangle. See, this triangle right here does not have to be a right triangle. Make sure you understand that. The law of sines works for all triangles. Okay, it's not just for right triangles. It works for all triangles. And so that's what we're going to do right here. The law of sines just basically says this. It says that the sine of any angle in a triangle, when compared to the side opposite, will be the same as the sine of any other angle when compared to the side opposite of it. And so while we'll never solve problems with this three-part proportion like this, it's just showing that this is true no matter which angle and opposite side you're talking about. It's always true. And this is crazy because it doesn't involve right triangles. We don't see any SOHCAHTOA going on here. We don't see any y over r, any of those things. We just have this really simple rule. And it's so easy to use. And so that's what we're going to do right now is we're going to go ahead and I'm going to show you some examples about how to do this. Okay, so here's another generic triangle. Go ahead and draw this one for me. And what I'm going to do is I'm going to say, hey, in this triangle, this is clearly about a 65-degree angle. And this one looks like it's about a 46-degree angle. And we'll call this side up here 17. Okay, and I'm going to call this X. I'm going to call this Y, and I'll call this capital Y since that's the angle up there, okay? Now, let's see. What I want to do is I want to see if I can use the law of sines to solve for that angle Y, side X, and side Y. And so what I'm going to do is I'm going to start with, I have to have an angle and the side opposite of it, okay? And that's what I have to do this. And so I do. I see that right here. I've got this 46-degree angle. So I can say the sine of 46 degrees is to 17 in the same way that, well, do I have another angle? Yeah, I got 65. Sine of 65 degrees is to X. Now notice, this is just a basic proportion with one unknown. To solve for a proportion like this, all you have to do is cross multiply. You multiply the top of one side times the bottom of the other side, multiply the top of the other side times the bottom of the other side, and you set those two things equal to each other. So in this case, I'm going to have X times the sine of 46 degrees is equal to 17 times the sine of 65 degrees. But I'm looking to get X all by itself, so I have to divide both sides by the sine of 46 degrees. These cancel out, and you'd be left with x is equal to 17 times the sine of 65 degrees all over the sine of 46 degrees. And that's when you grab a calculator. The nice thing about the law of sines is it uses the most basic math. I mean, you can see right here that this is pre-algebra level math. And then after that, you just plug things into a calculator. Got to make sure your calculator is on degree mode. And you got to be careful with the parentheses, making sure that you're closing parentheses and stuff like that. But for this one right here, and at this point, like I said, I plug it into a calculator. There's nothing else I can do. I get that x is about 21.4185, so on, so on, so on. So I'm going to say x is about 21.4. Now, here's the funny thing. I know in this problem, everything's pointing towards 2 sig figs, but I've been working with geometry students where we're constantly rounding to the nearest tenth. So I keep thinking, well, 21.4. If you were to tell me that it was 21, I would have no problem with that because that's accurate in terms of sig figs. But in a lot of these cases, I'm going to round to the nearest tenth. Okay? All right. Now let's figure out y. But to do that, I've got to get angle y, which hopefully everybody in the room realizes that's super duper easy because the 3 angles inside every triangle always add up to be 180. So you got 65 and 46, which give me 111. And so therefore, if I take that away from 180, I'm left with 69 degrees. So that's what this has to be up here, 69 degrees. Okay, now I'm going to start the exact same way I started the other one. I'm going to say that the sine of 46 is to 17 in the same way that, and this time I'm going to say the sine of 69 is to y. Okay, now I'm not going to use these numbers and this angle right here, the sine of 65, because these are approximate numbers. I always want to go back to the cleanest numbers I have, and so that's why I like this 17 and this 46 degrees. So again, you cross multiply, and you get that y times the sine of 46 degrees is equal to 17 times the sine of 69, and I just have to divide both sides by the sine of 46 degrees. Okay, I'm not sure if you can hear my dog in the background. Oh man, I'm crossing out all the wrong things, aren't I? Okay, supposed to be these two things cross out. So therefore, y is equal to 17 times the sine of 69 degrees divided by the sine of 46 degrees. So therefore, I plug that into the calculator. I got 17 times the sine of 69 degrees divided by the sine of 46 degrees. And I get about 22.063. You go 22.063, so that would be about 22.1. Okay, now let's see if these answers make sense. If this side down here was about 22.1, and this side up here was about 21.4, does that make sense? And here's how I look at it. With triangles, the smallest side should always be opposite the smallest angle. So here's the smallest angle, and opposite of it is the smallest side, 17. Here's the next smallest angle, and opposite of that is the next smallest side. And here's the largest angle, and opposite of that is the largest side. Another thing to notice is that 69 degrees and 65 degrees are pretty close. So it makes sense that the two sides opposite of them are pretty close. 21.4 and 22.1, that makes sense. Because this is almost an isosceles triangle, because it has two angles that are almost congruent. Okay? So that's what we're doing. This is the law of sines, and it is so easy. Okay, but now you get to try one. So here we go. Draw yourself another generic triangle. I drew an obtuse triangle this time. I'm going to tell you that this angle right here is 132 degrees. And if that's 132, I think that this one right here is about 21 degrees. And let's see here. I'm going to tell you that this long, really long side, it looks like it's about 43 inches, 43 feet, 43 centimeters, whatever. Okay, so here's what we're going to do. We're going to pause the video right here, and I want you guys to solve for this unknown side and this unknown side. Obviously, solving for that angle is really simple, so hopefully everybody can do that in like a heartbeat. But so pause the video right here, and in a second, we'll go through the answers of what x and y are. Okay, hopefully you have it. This is really simple. I say the sine of 132 is to 43. That's the one set that I have. I have 132 degrees, and the side opposite of that is 43, is equal to the sine of 21 degrees is to x. Cross multiply, you get that x times the sine of 132 is equal to 43 times the sine of 21 degrees. At that point, I divide both sides by the sine of 132. These cancel out. You're left with x is then about, and that's when I grab the calculator, 43 times the sine of 21, close the parentheses, divided by the sine of 132, close the parentheses, and I get 20.7359661. So I'm going to say, if I round to the nearest tenth, as I have been doing, I'm going to say it's about 20.7. Okay, so that's what x ends up being. It's about 20.7. Now, let's figure out that other angle. 21 plus the 132 gives me 153. And when I subtract the 153 from 180, that gives me 27 degrees. So this one's 27 degrees, which isn't too far off of 21, but it is kind of. And so we should expect that this side, y, is going to be bigger, and maybe even a chunk bigger than the side x, because the angle opposite of y is a little bit bigger. So I'm going to start with the same rhythm. Sine of 132 is to 43 in the same way that the sine of 27 is to y. Cross multiply, you get y times the sine of 132 is equal to 43 times the sine of 27 degrees. And you divide both sides by the sine of 132. Oops. There we go. These cancel out. And you get 43 times the sine of 27, close parentheses, divided by the sine of 132, close parentheses. And I get that y is about 26.2688. So I go y is about 26.3. 26.3. And does that make sense? Yeah. This is the smallest side opposite the smallest angle. This is the next smallest side opposite an angle a little bit bigger than it. And here's the largest side opposite the largest angle. So that really does make sense. Okay, all right. Now, I know after doing one, you're not a pro, or not everybody are pros yet. And so what I want you to do is I want you to try another. So I'm going to give you some numbers on this one, and let's see. Since we finished this, I'm going to kind of clear some room here. All right. Let's move that up. Okay, so for this one, we'll say I'm going to give you this angle right here is 109 degrees. This angle down here is about 27 degrees. Okay, I'm going to say that this is x, this is y. Go ahead and figure out what x and y are using law of sines. You just need one more piece of information. You, of course, need to know at least one of the sides. So I tell you that this side right here is 21. Okay, that side is 21. That's kind of a weird looking 2, so I'll try that again. Okay, that side's 21. All right, go ahead and figure out what x and y are. We'll pause the video right here, and then you guys can work through it, and I'll show you what I got in a second. All right, let's see what we did here. Again, law of sines has got to be the easiest thing in the world. You literally can't forget this. It's kind of like SOHCAHTOA. It just burns into your brain. I mean, that's such an easy system. So I'm going to first go, well, 27 plus the 109 gives me what, 136. If I subtract 136 from 180, I get 44 degrees. That's what's left for this one. So I know that the sine of 44 degrees is to 21 in the same way that the sine of 27 is to x. I can cross multiply and say x times the sine of 44 degrees is equal to 21 times the sine of 27 degrees. Divide both sides by the sine of 44 degrees. Okay, these cancel out, and I get x is equal to 21 times the sine of 27. So I say 21 times the sine of 27 divided by the sine of 44 degrees. Hit enter, and I get that x is about, hopefully you get the same thing. I got about 13.7. Okay, so I'm getting that x is about 13.7. All right, which makes sense because this angle opposite of it, 27, is the smallest angle. This was the medium size angle. And so the side should be smaller than this 21. And it is, it's 13.7. So now let's try the other one. I'm going to start it out the same way and say the sine of 44 degrees is to 21 in the same way that the sine of 109 degrees is to y. So we're going to cross multiply, get that y times the sine of 44 degrees is equal to 21 times the sine of 109. All right, divide both sides by the sine of 44 degrees. These cancel out. You get y is equal to, at this point, grab the calculator, 21 times the sine of 109, close the parentheses, divided by the sine of 44, close the parentheses, and I get 28.58. So it's about 28.6. 28.6. Okay, so we're saying that this, about 28.6, and I'll buy that. I think that makes sense. Even though the 109 degrees is way bigger than the 44 degrees, if you look at the length of this side and go, okay, this one is supposed to be 21, this other one, yeah, it would make sense that it's not gonna be like double, you know, it's not gonna be that big. So 28.6 makes sense. All right, okay, new kind of problem. Now that we've done these, and hopefully we're getting somewhat used to them, we're gonna apply these to a real life situation. And in fact, we're gonna do a problem that we have already done. And now we get to do that problem way easier, okay? Back a long time ago, we did a problem just like this, where we had a person who was standing some distance, some unknown distance from a building, and they measured the angle of elevation. In this case, it was 45 degrees. Then that person walked back, and in this case, 150 feet. They measured the angle of elevation again and found it to be 35 degrees. And using tangent, we were able to figure out the height of the building and the distance that they were initially from when they did their first measurement. And when we did this one, it became this massive, super ugly formula because of all the algebra we had to do. Now, the neat thing is, using law of sines, this becomes a very easy problem. It's a very, very basic problem. And so what I want to do right now is let's give everybody in here like 2 or 3 minutes to see if you can figure out how to do it. And once everybody kind of maybe throws their hands up in the air and says, nah, I can't do it, then let's unpause the video and we'll see what I'll show you how to do it. All right. I'm hoping that some people got all the way through, but I hope we didn't have to wait for so long that it made it frustrating. First of all, one thing I'm going to do is I'm going to say if this is a 45 degree, then outside right here is going to be 135 degrees. And then 35 plus 135 is 170. Which leaves this top angle to be 10 degrees. And see what I've done with that, then I've got this triangle right here. And now clearly, very much not a right triangle, but remember, that doesn't matter. We're not doing right triangle trigonometry anymore, and so it's okay that this is not a right triangle. And so with this, though, I can start to figure some other things out. Now think about it. I've got a side, this 150, and I've got a... Hang on, let's see here. I've got the side of 150 and I've got this angle of 10 degrees. So that's good. And so I can figure out the other things. I'm going to call this one X. I'm going to call this Y. So I could solve for X and I could solve for Y. And the question is, which one is more helpful? Well, when I look, X would make way more sense to solve because X is the hypotenuse of this right triangle right here. All right, it's the hypotenuse of that right triangle, and that right triangle has both the sides H and D, H for height and D for distance. So if I figure out what X is, then it'd be pretty easy to figure out what H is and what D is. Here's what I'm looking at. I'm going to start by saying, well, I know the sine of 10 degrees is to 150 in the same way that opposite of X would be sine of 35 degrees is to X. Cross multiply, you get X times the sine of 10 is equal to 150 times the sine of 35. Divide both sides by the sine of 10. These cancel out. You get X is about. Now, I'm going to put an approximate, but I'm not going to use it. I'm just giving it so we have an idea. 150 times the sine of 35 degrees, close the parentheses, divided by the sine of 10 degrees, close the parentheses. And I get that's about 495.5 or so, 495.5, somewhere around there. Again, I'm not going to reuse that number. That's just giving me an idea. Because now what I'm going to do is I'm going to say, let's look at that yellow triangle. If I was using basic right triangle trigonometry, I would know that the sine of 45 degrees is equal to opposite over hypotenuse, H over X. So to get H by itself, I'd multiply both sides by X. And I would know that H is equal to X times the sine of 45 degrees. And so what I can do is I said that this thing right here is what X is equal to. So I can plug that in for this and say H then is equal to 150 times the sine of 35 degrees divided by the sine of 10 degrees all times the sine of 45 degrees. That came from right here, okay? And so this will give me the most precise answer, because what I don't want to do is I don't want to come up with a decimal approximation and then plug that in and approximate again. So I'm going to take this whole thing right here, and this is going to be the most accurate answer I could come up with. So I got 150 times the sine of 35 degrees, close parentheses, divided by the sine of 10 degrees, close parentheses, times the sine of 45 degrees, close parentheses. I hit enter, and I get 350.346. I'm going to say, well, man, H is about 350. 350 feet. Okay? All right. I know I didn't go to the nearest tenth on that one, but man, 350 just looks so nice. And if I was rounding to the nearest whole number on this one, it would be 350 exactly. Okay? All right, now let's go ahead and find the distance. The distance right here, this d value, when you think about, if I know x is the hypotenuse, d is adjacent to 45. So adjacent to hypotenuse, that would be cosine. So I know that I'll do it up here. I know that the cosine of 45 degrees is equal to adjacent, which is d, over hypotenuse, which is x. Now, I'm not sure if you guys remember, but at this point, you really could be done. Because one of the things I did when I set up this and gave you this 45 degree angle, if anybody remembers, at 45, this is 90, this one would have to be 45. And what does that mean? That means that H and D would have to be the same measure. So I can go through all this work again, but I'm just going to get the same answer. The distance would have been 350 feet as well. Okay? So I'm not sure if you saw that before I mentioned it or not, but that made it pretty simple. Okay, what I want you to do now that we've done that is I want you to try another one just like it on your own. So here I've drawn, or poorly drawn, a cell phone tower, a cellular tower, okay? And then what I've done is giving you the two angles of elevation, saying, okay, at one spot, you found the angle of elevation to be 50 degrees. You walked back some 75 feet. You found the angle of elevation to be 45 degrees. So my goal is to go, okay, what is the distance you were initially, and what is the height of that tower? All right, so here's what I'm going to have you do. Give that a shot. We'll pause the video right here, and then we'll talk about it and see how you did. All right, well, let's see it. This is, again, super easy. I'm going to go ahead and get rid of this little stick man just to make this easy and go, okay, if 50 degrees is right here, then this angle's got to be 130. Why? Because these two have got to add up to be 180. All right, and then if you got 45 and 130, that makes 175. So this angle up here has got to be 5 degrees. And that angle up there is opposite of this 75. So that's how I get to start by setting up my law of sines. I can say the sine of 5 degrees is to 75, not 75 degrees, 75 feet, in the same way that, now remember I said I'm going to go up to this side, which is opposite of this 45, in the same way that the sine of 45 degrees is to x. So I'm going to go ahead and multiply, or cross multiply, so I get x times the sine of 5 degrees is equal to 75 times the sine, 75 times the sine of 45 degrees. Okay? All right, so then at this point, got to divide both sides by the sine of 5 degrees. These cancel out, and you get that x is about, and I'm just going to have a decimal approximation here, just so we have an idea. So I go 75 times the sine of 45, close the parentheses, divided by the sine of 5, close the parentheses. And I get 608.48, so, 608.48, ... All right? But I don't really want that number. The numbers that I want is I want what the height is, and I want what the distance is. So now I go back to using some basic right triangle trigonometry, and I know that the sine of that 50 degrees is going to be equal to opposite over hypotenuse, h over x. So I multiply both sides by x, and I get h is equal to x times the sine of 50 degrees. And here is what I said x is equal to. So I plug that in for this, and I get h is equal to 75 times the sine of 45 degrees over the sine of 5 degrees, all times the sine of 50 degrees. Okay? And I can do that all in one go. So I can say 75 times the sine of 45 degrees, close the parentheses, divided by the sine of 5 degrees, close the parentheses, times the sine of 50 degrees, close the parentheses. And when I do that, I get 466.12. So we're going to say the height is about 466 feet. All right? Now to find distance, notice this was not a 45-degree angle. I didn't have a 45, 90 again. So this time I'm going to use cosine, adjacent and hypotenuse. So I'm going to say the cosine of 50 degrees is equal to adjacent over hypotenuse. Multiply both sides by x. And you get d is equal to x times the cosine of 50 degrees. We look up here to figure out what was x. That's right here. There's our x. And so we go, okay, so I know that the distance is going to be equal to x, 75 feet, times the sine of 45 degrees, over the sine of 5 degrees, times the cosine of 50 degrees. Okay, plug that into my calculator. 75 times the sine of 45, close parentheses, divided by the sine of 5, close parentheses, times the cosine of 50, close parentheses. Hit enter. And I get 391.12. And so I go, okay, so D is about 391. Hopefully you got those exact same values, okay? What we're going to do is we're going to just do some practice. My hope is that by the end of this day, you have done Law of Sines so many times over that you are excellent at it, okay? Good luck.